dilute NaCl. The first step is NaCl ionize into Na plus Cl minus. In this water also present, therefore H2O ionize into H plus OH minus. In this dilute mean the solute is relatively smaller amount. Relatively solute is smaller amount. Therefore, this NaCl ionization is very small amount, therefore neglected amount. Which one this is? Neglected. Then which is considerable? This is considerable amount. Now second step is at anode. At anode, what is the charge? Positive. Therefore, actually which ion will come here? Cl minus and OH minus. OH minus actually come from which one? Water. Now which is negligible amount? Cl minus is negligible amount, therefore it is not used. We are using now which one? OH minus. OH minus actually come from water, therefore now H2O convert into O2 plus 4H plus 4 electron. For this oxygen 2 meaning here 2, 4 hydrogen, 4 electron. And its electrode potential value is 1.23 volt. Next, at cathode, third step is at cathode. At cathode, what is the charge? Negative charge. What are the ion will come here? Positively charged, Na plus and H plus. H plus actually come from water. Therefore, now this Na plus is negligible amount. This is neglected. Which is considerable now? Only this water molecule H plus is considerable. Therefore, now we can write here H2O. How many electron loss here? 4. Therefore, 4 electron will be gained. Now 4 electron gain and convert into H2 plus OH minus 4 electron. That's why here it is 4 minus 4 oxygen. That's why here 4 and 4 into 2 8 hydrogen. Therefore already 4 is there, 2 into 2 4 hydrogen balance. Its electrode potential value minus 0.83 volt. Now the net reaction is this 4 electron cancel, and here total 2H2O 4H2O, total 6H2O. This will be converted into O2 plus 2H2, and this 4H plus 4OH minus combine to form 4H2O. Now in this 4H2O cancel, how much left? 2H2O convert into O2 plus H2. This is a net equation. This is also known as a water electrolysis. Water electrolysis. In this, in this NaCl present, but due to NaCl, electrolysis process will be speed up, but it is not a NaCl electrolysis. Reason, it is very small amount, therefore it is also known as which one, water electrolysis. Due to NaCl electrolysis process will be speed up. Now, next in our textbook question given is aqueous AgNO3 by using platinum electrode electrolysis process. Then what will be the product at anode and cathode? So the first one is ionization step. AgNO3 ionize into Ag plus NO3 minus. Aqueous word given, therefore water also present, that will be converted into H plus OH minus. Now at anode, this is the first step, this is a second step. At anode, what is the charge? Positive. Which ion will be oxidized at anode? Negatively charged, that is OH minus actually comes from the water and NO3 minus. So now I am taking first one water, then our NO3 take here, NO3 minus convert into, there is no product. Reason, this one already at the +5 oxidation state, then nitrogen outer electron or valence electrons are 5, further there is no oxidation, further no oxidation, therefore this reaction now takes place. Then which will be oxidized here? OH minus mean actually come here, which one? Water. Then this water will undergo oxidation, then O2 plus 4H plus 4 electron, its electrode potential value 1.23 volt. Then here oxygen 2, then 2 into 2, 4 hydrogen, 4 electron, balance. Now next, third step, at cathode. At cathode, which ion will be reduced? One is Ag plus, another one is H plus. H plus actually from the water. Now we can take the reaction of Ag plus plus, here 4 electron loss, that's why 4 electron, then it will be converted into 4 Ag and converted into 4 Ag. 4 Ag plus converted to 4 Ag. Its electrode potential value is 0.80 volt. Next one, if you take the water, then H2O and then 4 electron convert into H2 and OH minus. 4 minus 4 electron, 4 minus, and 4 oxygen, 4 into 2 8, then 4 already, then 4 here, 2 into 2 4. Its electrode potential value is 0 minus 0.83 volt. At cathode, higher potential will be first reduced, therefore this the positive value is higher, this will be. And at anode already this one is a reaction oxidize. So this reaction will be takes place here at anode and cathode. This one reaction not takes place. This is not takes place. This is only preferable. Therefore, now together I will write here anode reaction, that is a positive, which one? H2O, that is 2H2O convert into O2 plus 4H plus 4 electron. At cathode negatively charged, that is 4Ag plus 4 electron convert into 4Ag. So what are the product form at anode? Oxygen is the product form at anode, and at cathode Ag is the product form that is deposited. This is about the aqueous Ag energy. This question is according to new textbook 2.18 question, exercise question. In that 1, 2, 3 anyone given. So I think this is the second one, like this. Next one is aqueous copper chloride using platinum electrode. Aqueous copper chloride by using platinum electrode. Now I am taking the first step is CuCl2 ionize into Cu plus 2Cl minus. In this, water also present, therefore H2O ionize into H plus OH minus. Now, second step is at anode. At anode, what is the charge? Positive. Therefore, negatively charged ion 2Cl minus and OH minus, that is actually from water. Then we know that 2Cl minus convert into Cl2 plus 2 electron. Its electrode potential value 1.36 volt, and water, then instead of OH means water takes place here, direct oxidation. This will be converted into O2 plus 4H plus 4 electron, then here 2H2O. Its electrode potential 1.23 volt. Actually, which one takes place reaction according to rules? Lower value at anode. So this is a lower value, mean this will be undergo oxidation, but actually this is the product. Reason, due to over potential of oxygen, which reaction takes place? This one reaction will be undergo oxidation, not this one. Therefore, now third step at cathode. At cathode, what is a charge? Negatively charged. In that, we will get positively charged ion Cu plus 2 and H plus. This is actually from water. Therefore, first Cu plus 2 takes a 2 electron and convert into Cu. Its electrode potential value 0.34 volt. In case H plus, that is from water, H2O plus 2 electron convert into H2 H2 and plus OH minus, that is here 2 electrons, 2 minus 2 oxygen, 2 into 2 4 hydrogen, 2 hydrogen balance. Its value minus 0.83 volt. At cathode, lower value will be first, sorry, higher value will be first reduce, then plus value is higher, therefore this will be reduced. This will be first reduced at cathode. So what are the tick marks is that I will write here. So at anode, what is that? There is a plus charge which will be oxidized here, 2Cl minus convert into Cl2 plus 2 electron. At cathode, that is minus, This will be Cu plus 2 electron convert into Cu. So these are the product at anode is a Cl2 and product at cathode is a Cu. Cl2 and Cu. Very, very important. This is also a question from exercise, that is 2.18 exercise question. In that it may be the third or fourth. Consider for example this is a fourth for important. Dilute H2SO4. This dilute H2SO4 first ionize into H2SO4 ionize into H plus that is 2H plus SO4 minus 2. Same thing, water also present, that will be ionized into H plus OH minus. Then what happened here? Dilute meaning here this is negligible amount, neglected amount this is. Then which will be undergo oxidation reduction, meaning water only, that is at anode. Anode mean positive. Which ion will be here? SO4 minus 2, and next one is OH minus, that is from water. Now this one is negligible amount, therefore this is only considerable amount. Therefore now reaction takes place is H2O convert into O2 plus 4H plus 4 electron. Then here 2 and this is 4 balanced 1.23 volt. Next, at cathode. At cathode negatively charged, and then positive ion will be reduced here, that is anyway H plus, this is from acid, and H plus this is from water. Anyway H plus is there, therefore H plus from acid, if already neglected, consider meaning H plus from water only, therefore H2O, that will be gain 4 electron and convert into H2 plus OH minus 4 mean 4 minus 4 oxygen, 4 into 2, then here 2 balance. Why I not wrote this acid mean this is anyway negligible amount, that's why this one takes place the reaction. So net reaction already given in the dilute NaCl. So direct I am writing after loss cancellation H2Os, 2 H2Os left, because this is 4H plus 4OH minus total 4H2O. Then this is 4H2O cancel. Then which is left, meaning 2H2O left, and 4 electron cancel. Therefore oxygen plus 2 hydrogen, that is a final product. This is also called product of electrolysis of water, because H2SO4 dilute. So this is a equation for dilute H2SO4. Next to at cathode, taking the concentrated H2SO4, then this concentrated H2SO4 ionize into H2SO4 ionize into 2H plus SO4 minus 2, and H2O ionize into H plus OH minus. This is now considerable amount. This is neglected amount. Therefore, at anode, which reaction takes place? At anode positively charged. Therefore, the negatively charged SO4 minus 2 will come, and OH minus. Anyway, this is negligible amount. This is considerable amount. Therefore, this one SO4 minus 2 is convert into S2O8 minus 2 plus 2 electron. Its potential value is here in book only 1.96 volt given or 2.05 given, nearly anyway higher value only this is. End of the textbook somewhere value is given, that is 2.05 volt given, and in the textbook explanation 1.96 given, anyway higher value this one only. And this is at anode reaction, OH minus is negligible, not writing here. Next, at cathode. At cathode, which one negatively charged, then which ion will come here positively charged, that is H plus from acid, that is H2SO4, and H plus, that is from water. Anyway, this is a negligible amount, this is considerable amount, therefore H plus, that is 2H plus 2 electron convert into H2, its potential value 0 volt. Then what are the product at anode? Anode is S2O8, at cathode which one? H2. So keep in mind this reaction very important. Concentrated H2SO4, dilute H2SO4, very important for PU exam also, for competitive exam also. But sometimes they may use here another word, low charge density, mean dilute, consider H2SO4, and high charge density, that is called concentrated H2SO4. Sometimes instead of dilute concentrated they may use low charge density and high charge density word they may use. So careful, very important for PU and competitive or board level exam and competitive level exam. Next one, very important. Now by using active electrodes, example given in our question 2.18, I think this is the first question. What is that? Electrolysis of aqueous AgNO3 by using silver electrode. Which electrode? Silver electrode. Now the first step, we know that ionization, AgNO3 ionize into Ag plus NO3 minus. In this water also present, therefore H plus OH minus. Second step is at anode. At anode, what is the charge? Plus. Therefore, which ion will be oxidized here? One is NO3 minus, another is OH minus, that is actually from water. Now we know that this will not undergo oxidation. Reason, NO3 minus convert into no product. Reason, already this is at the +5 oxidation state, no further oxidation, therefore this reaction not takes place. Which one takes place now? Water, that is H2O convert into which one? Oxygen plus 4H plus 4 electron. This will be 2, and here electrode potential 1.23 volt. Next, at cathode. At cathode, what is the charge? At cathode, negatively charged. At this one, Eg, sorry, volt, and here Ag also is there, that is active electrode. Therefore we can write here Ag reaction also. Ag is converted into Ag plus plus electron. Therefore, its electrode potential is 0.83 volt. At anode, lower value will be first oxidized. So, because why I wrote mean Ag is active in the question given active electrode. Therefore, Ag also undergo oxidation. Now, what is the product at anode? Ag plus. Now, at cathode. At cathode, what are the ion will becomes here? At cathode, positively charged, that is a Ag plus will come here and H plus will come here. This is from water. So I am writing here Ag plus electron convert into Ag. Water undergo reduction. Then this will be converted to H2 and 2OH minus. Ag plus converted into Ag electrode potential 0.83 volt, and this H2O converted to minus 0.8380. This is 83 volt. So higher value first oxidize. Therefore, here preferable reaction at anode is this one. At cathode is higher value preferable this one. Anyway, at anode is 1.23. This is 0.83. Lower value mean Ag undergo oxidation, and at cathode Ag plus undergo a reduction. This will be reduction. This will be oxidation. So overall reaction at anode, which reaction? Ag convert into Ag plus electron. At cathode, Ag plus electron convert into Ag. So this is a at anode reaction and cathode reaction. Now the final one is CuSO4 aqueous solution by using which electrode? Copper electrode. Copper electrode. Now, first step, what is that? CuSO4 ionized into Cu plus 2 plus SO4 minus 2. Water ionized into H plus OH minus. Now, at anode, which ion will be oxidized? Now copper is active electrode is there, then copper also, it is not positive charge but copper undergo oxidation. And now SO4 minus 2 and OH minus. Therefore, what will be happen here? Cu convert into Cu plus 2 plus 2 electron. Its electrode potential 0.34 volt, and OH minus or SO4 minus 2 convert into no reaction because it's already in the highest oxidation state, plus 6 oxidation state. Then you may ask the question, in concentrated H2SO4 we wrote, because here in that case there is no any other ion to undergo oxidation. That's why SO4 minus convert into S2O8 power minus 2. That's why that is possible. But in general, when other ions are present, this will not preferable reaction. And water reaction already we know, H2O convert into H2, sorry, O2 plus 4H plus 4 electron, therefore here 4, its electrode potential 1.23 volt. Then according to lower value will undergo oxidation, therefore which one here? This will undergo oxidation. Next, at cathode, what is the charge? Negative. Therefore positively charged ion will come, that is H plus and H plus only, and Cu plus 2. Now H plus mean we know that water undergo reduction and convert into, because this H plus from the water only, therefore it convert into H2 plus 2OH minus, then here 2, and this value is minus 0.83 volt. Copper ion undergo oxidation reduction, then 2 electron convert into Cu, therefore its value is 0.34 volt. Now observe, at cathode higher value first reduce, therefore this is a higher value than minus 0.83, this one. Totally overall reaction at anode, which reaction takes place? Cu convert into Cu plus 2 electron. At cathode, this Cu plus 2 convert into Cu by taking 2 electron. Therefore, at anode product is Cu plus 2, at cathode product is Cu. This is a very important. So overall conclusion what you drawn from this all, when active electrode present, active electrode only oxidize at anode and that ion will be reduced at cathode. Then only confusion you will get at aqueous solution given, mean that time you will get the difficulty, and when inert electrode is given. So carefully you have to analyze with the values also I explain. I hope you understood properly. If any doubt is there, comment, then I will explain.